All right, let's go ahead and get started. We're going to begin our coverage of yet another case study, and this one is going to be very relevant for the current assignment, assignment 2C. This is called the Reactive QuoteServices App case study. This is a reactive variant of an earlier case study we looked at that used Spring WebMVC, except this time we're going to show how to use Spring WebFlux in order to provide access to two different quote services, one of which provides Jack Handey quotes, and the other which provides Zippy the Pinhead quotes. And we'll see how this works to send and process HTTP GET and POST requests and responses asynchronously. This particular case study is going to demonstrate a lot of things we've talked about. It's going to use a gateway so that the client only talks to the gateway, and then the gateway works in conjunction with the Eureka Discovery service to forward the requests to the appropriate microservices. All these microservices, including the gateway, will register with Eureka when they start up. So Eureka, of course, has to start first when you run the program. If you run it in the integration mode, you'll see how that all works. It should be very, very typical to what we've already been doing. The client will send requests to the API gateway, and only the API gateway. It doesn't talk to the microservices directly. That's, again, no surprise based on what we've seen so far. And when the gateway receives the request, it uses Eureka to find where the various microservices are running, and then it routes the request to those microservices. As you'll see, the nice thing about using Eureka is we don't have to hard code ports and host names anywhere. It takes care of all this stuff. This is also commonly known as the server-side discovery service. And then there are two different implementations of the quote services. They both use persistence. The first one, called the Handey microservice application, uses the R2DBC reactive database mechanism in order to be able to give quotes back when the gateway forwards it the HTTP request. And you can see here, of course, that those requests flow back through the gateway back to the client. In contrast, the Zippy microservice uses the Java persistence architecture to respond with quotes when it gets requests from the API gateway. So let's talk quickly about the structure of this. There's a lot of moving parts here, basically different module for every different piece of the puzzle. That's also almost identical to the structure of your assignment 2C, although there are differences because, of course, they're doing different things. Eureka contains the entry point for the discovery service. Pretty much everything is declarative. It also defines the port numbers that Eureka listens on, which have to be known by the other microservices. That's really about the only fixed port number is the one that we're going to use for Eureka, and also, of course, the gateway, too. The gateway is also almost entirely declarative, just a few little things you have to write in Java code, and it configures the gateway to use the Eureka Discovery service using a YAML file, and that also specifies the port number that it's exposed. So there's really, again, very few fixed port numbers needed here. The microservices are where things get fun. So the microservices actually do the work. Both microservices are going to return reactive types to the caller. And the Zippy microservice does that. The Handey microservice does that. However, the implementation's a tad bit different because the Zippy microservice uses the JPA database, and that does not work with reactive types. It uses classic Java types like lists and so on. And so even though we have a reactive interface from the client point of view, under the hood, things are still returned to the service in the form of reactive types, or of non-reactive types. And then we have to adapt them. Not ideal. We'll talk more about that in a second. Then there's a resources project that has a whole slew of different application property files, things that are done in YAML to describe how this is going to be configured, the microservice name, how to connect to the Eureka configuration, because it's a client for Eureka. We also have schema definitions in SQL, as well as data that's in an SQL-style format to populate the Zippy microservices JPA database with quotes from Zippy the Pinhead. The Handey microservice also returns reactive types, but it's the interface to the R2DBC database. And that uses reactive types through and through. So way more cool than what we have with the JPA by itself. So it's more reactive, more consistently reactive. The Handey microservice also has all these YAML files and SQL files to configure it in a very declarative fashion. Again, we're not having to write a lot of imperative code, especially for the Handey microservice. In fact, when we get to the code walkthrough, you'll see we actually could wire up the Handey controller to talk directly to the quote repository rather than going through a service, because the service really doesn't add any value here. It does add value for the Zippy microservice, but it adds no value for the Handey microservice. Probably should get rid of it. And then you can see we have a common module, and these are classes that are shared by the microservices, things like the base application, which we'll talk about, the quote schema, which is used to send the quote information back and forth, and various other files that we need. There's also some helper classes that are reused by the other projects. Most importantly is this thing called array utils, and that's needed by the R2DBC implementation for some reasons we'll talk about as we get there. Looking at the client, from the client point of view, we have a really cool test driver that causes the client to asynchronously send and receive requests and responses to the API gateway, and it runs on the server and it displays the results. This is handled in a very clever way by some proxies. We have this quote proxy mechanism, and this is implemented using Spring 6 and or Spring 7, Spring 6 plus, whatever comes after Spring 6 and beyond. It uses the HTTP interface client feature in order to be able to abstract away proxy implementations. There's also a slew of other common files that are used and shared between the clients and the servers, and some other helper classes that are used by various things. Something else that's just worth pointing out here on the client side, you can enable and disable logging. This may be helpful for you when you test your program, if you run it in integration mode, because if things go wrong, you want to know that things are going wrong. You want to know, for example, if you don't wire beans correctly or if an exception occurs. But when things are working, you may want to disable a lot of those logging messages because they're very obtrusive and annoying after a while. Okay, so that's just a quick overview of this project. And you'll see when we go through it in more detail how this corresponds structurally in many ways and also from the point of view of implementation artifacts to assignment 2C.